Hey guys, Rohan this side and welcome to my YouTube channel. Let's start today's problem of the day on Geeks for Geeks. It is median of subarray. Okay, the what exactly the question given here is, it's a we have three things: array A, integer n, and integer m. Okay, then what is the integer n? N is nothing but the length of array A, and m is nothing but the given median. Okay, so we need to find the sub array which includes this median m. Okay, whatever the value is there for m, that includes in that sub array, and the another thing is that median of that sub array should be equal to this m. Okay, so how we get the median? If the two things given here, it's like if n is odd, then we can say the length of array is odd, then the middle number is nothing. After sorting the array, middle, whatever the middle value we are giving get now, that is nothing but the median. And if it is even, then the two middle numbers after sorting, and we just select the left of the two middle numbers after sorting the array. Okay, so these two condition to find the median, and after that we need to check that is it equal with this m or not, and that m should be into that sub array. So we have these three condition to check that sub array, and if it is satisfied, then we can increase the count. So we just need to find how many sub arrays we are getting from this array which satisfy these three conditions. Okay, so for that, let's start coding. First of all, we'll just define one function to find the median. Okay, as the rules given here, we'll just find the median first. We can say the function median with some list, we can say L. Okay, then first we just need to sort this list. We can say sorted L. Okay, now first condition we just put it like, if the length is length of this L is module 2 is not equal to 0. Okay, so if it is a odd, then we'll just select like some variable A is nothing but the integer of length of L divide by 2. Okay, then let's select that it is odd. This is the odd one. Okay, then it is a 5, and if we are divide by this 2, then we'll just get it like 2.5. and if it is the integer, then we can just say that it's 2. Okay, and if we just putting like 2, then it is not the correct. We just need to add 1 into that. Okay, and after that we can say we'll just get the correct value like 3. So 1, 2, 3, 4 and 5. Okay, so whatever the okay, sorry, here it is start from 0, so no need to add 1. Okay, then we'll just get only 0, 1, 2, 3, 4. So 2 is nothing but the middle value. Okay, and after that the same, if it is not the odd one, then it is even, then we'll just select like A is equal to integer of length of L divide by 2. Okay, then we can say this is normal, and as we need to select the left one, then we'll just need to just do -1. Okay, then we can say this is we are just getting the index. Okay, and from that index we'll just return length of, sorry, not length but list of index A. Okay, now we are ready with the median part. Then let me just write a function. Okay, I think I just deleted one thing here. We just need to write the main function first. Def of count subarray of, we have self comma and comma e comma n. Okay, and let's put all this inside that. Okay, and after this median, let's start selecting the subarray. Okay, for the subarray we'll just select like for I in range of n, this is the big N, plus 1, and the second loop to find the another j value in range of range of I. Okay, then we have starting from 0, 0 to 1, 0 to 2, 0 to 3, and 1 to 2, 1 to 3, and so on. Okay, then we have a subarray. Now we just need to select two things, like the two conditions. We have a median and the value m. So if m in, okay, so what is the exit subarray? We are just using the slicing here with the I and j. So from j to I. Okay, and this is this a of j to I is nothing but the subarray. Based on this for loop, we are just getting the different values there to find all, to select all the subarrays. Okay, and if m is there, then we'll just check the another condition for the median. Okay, now here we are just calling that median function, which we already write above. Median of a of j colon I is equal to m. Okay, if both the conditions satisfies, then we just increase count plus equals to 1. Okay, for that we need to define a count first. Count is equal to 0. Okay, and at the end we'll just return count. Okay, that's it. Let me compile this now. Okay, I just forgot this column here. Okay, now it's compiling for the first test case. Okay, local variable j reference before assignment. Why this is the error? Okay, let me check. For I in a range of n plus 1, for I in a range, okay, this should not be j, this should be I. Okay, and let me run it again for the first test case. Okay, we could see that the first test case satisfies fine. So this is the correct logic. We are just checking all the condition with the median. Okay, let me submit this. Mostly if we check the time complexity here in the given problem, we need to solve this in the O of n time complexity, but here we are just using 2 for loop. Okay, so it is more than that, it is O of n square. Still, let me try to submit it. Let's see how many test cases we can pass with this code. Okay, only 223 test cases we pass, and we just reach to the time limit exit. Okay, so we can say this is the correct code, but we are using nested for loop. So due to that only it is like we are not able to pass all the test case. So let's use another approach here. Okay guys, so for the second approach I already write the code now here. Okay, so in how we use the second approach, it is nothing like in place of finding the subarray, we are using some pointers, okay, to get the count. Okay, so first here we just write this recursion function. For that we needed two things. We just find the count with the m value and count with the median of m plus 1, because if we are sorting this, then it is like 1 2 3 4 and 5, and if we are finding the median, then we'll get the median is 3. Okay, so it is like but we need a m value is nothing but 2, so we are just getting like these two things, and whatever the values we are getting, whatever the count we are getting with the median 2, and whatever the count we are getting with the median m plus 1, okay, we are just subtracting that a minus b. Okay, so what is this recursion function and how we get the count? Okay, so first of all, what we'll do here, we'll just get one array of zeros. Okay, and what we'll find here, it is like how many zeros? It is like n plus 1 into 2. Okay, why we are doing this n plus 1 into 2? Like we are just putting like put pointers, and if we are getting the correct value, then we can increase it, and if it is wrong, then we can decrease it. So we are just starting from the middle point, and if all the values of this particular array is greater than the value m, then this will continuously increase the value. So if we are starting from the middle point, like we can say 7, and all the 5 values are correct, like greater than or equal to the value m, then we need to reach to 11, and if it is less, then we just reach to 1. Okay, that's why we are just using 2 into n plus 1. Okay, and we are just putting like one pointer is nothing but the current. We for that we are just giving the value n, the another is y, and one another value we are getting in answer. Okay, whatever the, like in every loop we are increasing the answer, and here we can say this answer is nothing but the count of all the values. Okay, and another is initially, as I say, we are just starting from the midpoint, or we can say the n. Okay, so L of current value is equal to whatever value, like mostly at the initial point it is 0, so we are just increasing that to 1. Okay, so at currently we are at this in this list L, we are at the value of the n. Okay, and based on the another loops, we'll just either increase, either decrease. Okay, so now we have a n value here as the function. I just write here small n, a, and m. Okay, so from that we are just finding this first loop. Okay, initially we are just putting like x is equal to -1. Okay, as I said, we just need to check like the value is greater than or equal to m or not. If it is greater than or equal to m, then we'll just change this -1 to 1. Okay, and after that again we check if the x value is 1. Okay, if x value is 1, then we'll just go into the else loop, or we can say not only 1, whatever the value apart from -1. So condition is x is equal to -1. So with this, what we can say that if when we have x is equal to -1, when this condition a of I, which is less than m, that satisfies. Okay, here if greater than, then we'll definitely change x to 1. Okay, but if it is less than, will not change, and we can say this x is nothing but the one flag to find it, like whatever the array value we are having, that is greater than or equal to m or not. Okay, and if it is less than, then we'll just decrease value y with the whatever the current value we have. Like currently we have at first I is equal to 0. For that we have y value is 0, and L of current is nothing but the 5 plus x. Okay, plus here is nothing but the -1. X value is -1, so is L of 0. L of 0 is nothing but that initially 0. So y value, it is at the 0 only. Okay, and if it is a greater than value, then we can say that 0 plus whatever the if it is greater, then we'll just increase the value y, because it is like we are just adding the current value, and current value we already increased to 1. Okay, here we could see we already increased to 1, that's why we are just adding that, and we can say that y will increase with that. Okay, and after this condition completes, we have just 3 steps to do. First, we'll increase like current is equal to current plus x. Okay, whatever the x value we have, if it is a 1, then we'll just increase it, and if it is a -1, then we'll just decrease it. As I said, at the every step we'll just increase that current pointer. Either if all the values satisfy, say all the value greater than m or equal to m, then we can say that we just increase up to the 11, or if it is less than, then we just decrease down to the 1. Okay, for this particular case, because we have a n value 5. Okay, and if it is everything is goes correct, and if we increase the value y, then we'll just store into the answer whatever the answer value we have, we'll just add the value y into that answer. Okay, and at the end we are just increasing the whatever the value is. You can see the initially we'll just increase, but after this for loop, every for loop we need to increase the whatever the current value we have in that list, we'll just increase that to 1. Okay, if it is 0, then 1, 1, then 2, as it is. Okay, so if we traverse this all the code, okay, for the first test case, then we can say that for the first this n, am, and we'll get the some value, and after that if we'll select m plus 1, then for that same way we are just getting this value. Okay, and at the end if we are subtracting that, then we'll just get the exact count here, like 3, like for whatever the sub arrays we are having, all this condition satisfies. Okay, so for that this is the solution. Let me submit this. Let me first try for the first test case, and for the first test case it is satisfies fine, and let me submit it for the remaining. And for the remaining 1000 plus test case, we could see this solution is fine. So we can say that two approach, the first with the n square complexity, and another this pointer approach is for the less time complexity. So this is the solution for today's problem of the day, guys, and thanks for watching this video. Please like, share and subscribe to my YouTube channel. Thank you, guys.